Welcome everyone. Let's see what actually happens when you run yarn install. So if you use Yarn, you probably have run yarn install many times, and you might have wondered what's actually happening during the install. So if you understand what steps are part of the install, you can actually understand how they affect performance and why running yarn install sometimes is fast, other times is slower. So the installation basically consists of 3 steps. First, we have the resolution, then we have the fetch, and finally we have the link. The first step of the installation is the resolution step. In this step, Yarn will look at the package.json files and the yarn.lock to find which entries are missing from the yarn.lock. Then, for each missing entry, it will resolve it via the resolver, which basically turns a dependency specified by its name and a version range into something that has a specific version of that dependency. So for example, here we have React 18.00 pinned to the major. So we resolved it to exactly version 18.2.0 and also into the dependencies. What are the dependencies of this specific version of React DOM? In this case, we have 2 dependencies and also 1 peer dependency. So indeed, if we look at the typical project, which has many dependencies and dev dependencies, we will see in the yarn.lock an entry for each one of these. And for example, in this case, we can see that we have React DOM at version 18.00 pinned to the major, which has been resolved at version 18.2.0, which has these dependencies and these peer dependencies. Next, Yarn will look at the transitive dependencies and find which entries are missing. So you can see that the transitive dependencies of React DOM in this case are these 2, loosenify and scheduler. So Yarn will look again at these and see, okay, do I have an entry for these? If not, I actually need to do the same thing that I just did for React DOM. And so for each missing entry, we'll resolve it again via the resolver. And then we repeat this process until all entries are resolved. Once this is done, the yarn.lock has all the entries that it needs, and unnecessary entries that might have been there before are removed. And with that, the resolution step is complete. So let's actually see how the performance of the resolution step is affected. When is the resolution step the fastest and when is it the slowest? So obviously, the resolution step will be the fastest when the yarn.lock is up to date. So you already have there all the entries and you don't have any extra entries. So Yarn already sees that you already have everything, it's up to date, so it's very quick, it basically is instant. On the other hand, it will be the slowest when the yarn.lock needs to be generated from scratch, because this means that Yarn needs to resolve all entries for your dependencies and all the transitive dependencies, so that might take some time. And then of course you have everything in between in the case in which the yarn.lock is not up to date, but it already has many entries in it, so some entries need to be resolved. Next, we have the fetch step. So once Yarn has resolved the entire dependency tree, it will iterate over that dependency tree, checking for each package if it's in the cache. And then for all the packages that are not in the cache, it will retrieve that package, for example, from a remote registry or from a location on disk, depending on how that package has been defined. And now, after this has been done, the cache has all the packages that it needs for the entire dependency tree. And all the necessary packages that were in the cache are removed. So if you remove a dependency, everything that was in the cache related to that dependency is also removed. So we can see here that inside .yarn/cache, we have all the packages that are part of our dependency tree as zip files. This is the location of the cache, the default location, but you can of course change this location. And also Yarn might be using a global cache, so a global location, not per project. And this is actually going to be the default since Yarn v4. But unless you actually have the global cache, you will actually see the cache locally to your project like we see here. Okay, let's actually now see what affects the fetch step performance. So of course, it will be the fastest when the cache is up to date. So you already have everything there and you don't have anything extra. So Yarn already sees that you're good. So it's very quick. It will be the slowest when the cache needs to be generated from scratch. So when Yarn needs to fetch the entire dependency tree and put it in the cache. And of course, then there is everything in between when the cache is partially up to date. So you have already something in the cache, then you add some new dependencies. So Yarn will only need to fetch those new dependencies and put them in the cache. Okay, once we have the dependency tree and we have all the packages in the cache, comes the link step. And the link step is basically having a linker which uses the dependency tree that we constructed and the cache to write packages on disk in a way that can be consumed by, say, a node application. And basically, you might have different types of linkers. You could have a node modules linker, and in this case, it will generate the entire node modules directory. Or you could have a PnP linker, which will generate a .pnp.cjs file. Once that completes, Yarn will run the build scripts like post install for packages that define them. So basically, you might have some packages that need to run something after they have been installed on disk. So this is the phase in which Yarn will run those scripts. And of course, these build scripts are only run if they have not been run before, or if they have been run before but the dependency tree for that package changed. So Yarn is also somehow smart here to know, do I actually need to run the build script or have I run it already before and it's up to date? Let's actually see what affects the performance of the link step. So of course, the link step is the fastest when the node modules or the pnp.cjs file, in case you use PnP, are up to date and no build scripts need to run. And of course, it will be the slowest when the node modules or the pnp.cjs need to be generated from scratch and all build scripts need to run. And then you have everything in between when the node modules or the pnp.cjs are partially up to date and some build scripts need to run. Also note that a linker plays a big role in the performance of this phase. So the PnP linker is much faster than the node modules linker in all scenarios. In fact, in the slowest case, it might be orders of magnitudes faster. And that's it. That's actually what happens during Yarn install on a high level. So now you should have a clear idea of what is happening, what are the different steps, what Yarn is doing in each step, and what affects the performance of each step. So now when you run Yarn, you can see if some particular step is taking longer than others, you can understand why this is happening. And that's it. See you in the next one.